This is a warm-up for the entire 8th grade, which is calculating and using the slope or the constant of proportionality for linear relationships that are proportional. In other words, their graphs go through the origin, and eventually it moves to part 4, which is calculating and using the slope for linear relationships that are not proportional. So their graphs do not go through the origin. This is a list of the steps that I use to solve these problems. So there is a right triangle, and the horizontal side of that right triangle lies right on the x-axis. The vertical side of that same right triangle is parallel to the vertical axis or to the y-axis, and the hypotenuse is the line in question. It connects with the origin. It runs right through the origin, and the left vertex of that right triangle sits right at the origin. Therefore, that line identifies a proportional relationship. Here are a bunch of randomly selected points. Each of these points is connected to the origin. So each of these line segments then is the hypotenuse of a right triangle. And I'm going to compare the slope of that hypotenuse, the slope of this line segment, to a slope of 1. So a slope of 1 means that the vertical length is equal to the horizontal length. So the vertical length is 1 times the horizontal length. So in this case, the vertical length is 5 units. The horizontal length is 5 units. The vertical length is 10 units out to here. The horizontal length is 10 units out to here. So those lengths are equal. So now if we just pick one of these points, this point right up here, complete the right triangle. This right triangle has a horizontal length of 3 units right here. 1, 2, 3. Its vertical length is 13 units. So it's 13 units from this horizontal axis, or the x-axis, up to this point right here. And that length is 13/3 of this length right here. Why thirds? Because there are 3 units. So this 1 unit is 1/3 of 3. 2 units is 2/3 of 3. 3 units is 3/3 of 3, and so on. And if you keep going up this way, you'll get up to 13/3 of these 3 units. So this point is at 313. And so the vertical length is 13/3 times the horizontal length. So any point on this line, if you draw a right triangle, its vertical length is going to be 13/3 times the horizontal length. Compare that to a slope of 1. This 13/3 is a value that's larger than 1 because its vertical length is more than 1 times its horizontal length. So if it were a slope of 1, the vertical length would be 1 times the horizontal length. So in this right triangle, this vertical length, once again, is 13/3 times the horizontal length. So here's that same horizontal length right here, and its length is 13/3 times these 3 units. So imagine you have 3 chocolates, and I said, give me 13/3 of those 3 chocolates. We're going to take those 3 chocolates, divide them into 3 equal parts, and give me 13 of those parts. So that 13 chocolates is 13/3 of these 3 chocolates. So the vertical length is 13/3 times as long as 3. So 13/3 times 3 equals 13. These 3's cancel, you're left with 13. So the vertical length, y, is equal to 13 units. Now if x is 1, y is equal to 13/3 because 13/3, or 4 1/3, is 13/3 times 1. If x were equal to 2, y would equal 26/3. Well, 26/3 is 8 2/3. So this is 8 right here. 1, 2, 3, 4, 5, 6, 7, 8 2/3. 3 times 13/3 is 39/3. So 3 times 13/3 is 39/3, or 13 right here. So with practice, this will begin to make sense. I'm going to go through the same thinking 3 more times. So here's the next point right here. And if you complete its right triangle, the length along the horizontal side is 11 units, and the length along the vertical side is 8 units. So those 8 units are 8/11ths of 11 units. And 8/11ths is less than 1. So this slope is going to be less than 1, because 8/11ths of 11 is 8, where 11/11ths, if it were 1, that would be 11/11ths, or 1 times 11, or 11. So this is 8/11ths. So this point right here is 11, 8, and this vertical length is 8/11ths of whatever the length is for x. So anywhere on this line, the vertical length is going to be 8/11ths of the horizontal length. So here are those 8/11ths right here. And so again, use an example of chocolates. If you have 11 chocolates and I say to you, give me 8/11ths of those 11 chocolates, you're going to take those 11 chocolates, divide them into 11 equal parts, and give me 8 of them. So 8/11ths of 11 equals 8. 8/11ths of 11 equals 8. Now if x is 1, y is equal to 8/11ths, because 8/11ths times 1 is 8/11ths. If x is 2, then y is 16/11ths. So that's 1 and 5/11ths. If x is 3, 8 times 3 is 24/11ths. So that's 2/11ths more than 2. If x is 4, 4 times 8 is 32/11ths. 3 would be 33/11ths, so that's 1/11th less than 3. If x is 5, 8 times 5 is 40/11ths, so that's 7/11ths more than 3. So this is 3 right here, this is 1/11th less, this is 7/11ths more than 3, so a little bit more than halfway between 3 and 4. This is the point that I just did. And so now the next point is right here. So now we're going to talk about force, because this horizontal length is 4 units. So the vertical length is going to be a fraction of those 4 units. So it's going to be force. So this is 4 units. This vertical length is 9 units. So this length is 9/4 of these 4 units. So this is 1/4 of 4. 2/4 of 4, 3/4 of 4, and 4/4 of 4. So slope of 1 would be 4/4 of 4. So 1/4, 2/4, 3/4, 4/4 of 4. So 1 times 4 equals 4. This would be 5/4 of 4, 6/4, 7/4, 8/4, and 9/4 of 4. So here's the point right here. It is at 4, 9. So this vertical length is 9/4 the horizontal length. So whatever the horizontal length is along this line here, the vertical length will be 9/4 of that length. So here's the 9/4 right here. So 9 units out. This is 1/4, 2/4, 3/4, 4/4 of 4. 5/4, 6/4, 7/4, 8/4, 9/4 of 4 is equal to 9. So this point right here is 9 units, and along this vertical side, this is 9 units, which is 9/4 of 4, when x equals 4. So 9/4 of 4 is equal to 9. Now if x is 1, y will be 9/4, because 9/4 times 1 is 9/4. 9/4 is the same as 2 and 1/4. So 1 times 9/4 is 9/4, a little bit more than 2. 2 times 9/4 is 18/4. Well, that's 4 and 2/4, about 4.5. So 1, 2, 3, 4, and 1/2 right there. 3 times 9/4 is 27/4. Well, 27/4 is 6 and 3/4. 24/4 is 6. 3 more fourths gets you to 27/4. So this is 6, 1, 2, 3, 4, 5, 6, and 3/4. And 4 times 9/4 is 36/4. 36 divided by 4 is equal to 9. So this gets you up to 9. And the last point is right here. So I switched the coordinates. So this is now 9, 4. So now we're going to talk about ninths. So this length is ninths, a fraction of this length. And this length is 4/9 of these 9 units. So this is 9 units long, the horizontal length. The vertical length is a fraction of 9. If it were 9 units, it would have a slope of 1. They would be equal lengths. So they would be 1 times 9 would be 9. But it's not. It's a fraction. It's less than 1. So it's 4/9 of 9. So this is 1/9, 2/9, 3/9, 4/9 of 9. So here are the 4 units. This point is out at 9, 4. So this vertical length is 4/9 of whatever the horizontal length is. So anywhere along this line, the vertical length is 4/9 of the horizontal length. Well, the horizontal length in this case is 9 units. So again, if I had 9 chocolates and you said, give me 4/9 of those 9 chocolates, you'd look at those as 9 equal parts or ninths, and you would give me 4 of them. So 4/9 of 9 is equal to 4. It's right here. 4/9 of 9 is equal to 4. Now if x is 1, y is equal to 4/9. If x is 2, 2 times 4 is 8/9. So it's just a little bit less than 1 right here. It's 1/9 less than 1. If x is 3, 3 times 4 is 12/9. 12/9 is 1 1/3, or 1 3/9. If x is 4, 4 times 4 is 16/9. That's 18/9 would be 2, so that's 2/9 less than 2, 16/9. And so on, until you get up to 9 times 4/9 is 36/9. 36 divided by 9, so 36/9. 36 divided by 9 is 4. So you have a whole bunch of points to choose from. Continue in this thinking, expand your thinking to other quadrants, and continue to work on your understanding of slope and constant proportionality.